look at plugging in algebraically to find limits when plugging in doesn't look like it works. So when you get 0 over 0, that's called an indeterminate form. And we can't work with that, so okay, what do we do? What's our strategy if we plug in and get 0, 0? Because most of the time in the AP test, when you plug in, it's not going to work right away, because that's just like too easy. So they're going to ask you to do some other stuff to find it. So let's just start doing some examples, and we'll practice that. So I got limit as x approaches 5 of x minus 5 over x squared minus 25. So you can see right here, if I plug in 5, I'm going to get 0 on the top and 0 on the bottom. And that's an indeterminate form. It tells me that that method's not going to work, so I'm going to try to work around it. So what I see here is if I look at the bottom, I can factor that. And this becomes limit as x approaches 5 of x minus 5, and nothing I can do on top, over, this is the difference of two squares. So the first thing squared minus the second thing squared, so I can take the square root of both of those. So the square root of x squared is x, put that in those two spots, square root of 25 is 5, put that in those two spots and throw the plus minus there. Then those will go away. And what I really end up with is the limit as x approaches 5 of 1 over x plus 5. So this is going on top, but you have to have something on top. And now, if I plug in 5, it'll work. So now I get 1 over 5 plus 5, so you plug in the 5 in for x. And your answer is 1 10. So we tried to plug in, it didn't work. Then we tried another method to kind of work around it, and then we get what we need. Alright, I'm just going to keep throwing more examples at you. So let's say the limit as x approaches 6 of 6 minus x over x squared minus 36. This is similar, but there's a little twist to this one. If I plug in, I'm still going to get 0 over 0. So if I factor the bottom, I will get, there's two ways you can do this. I will get x plus 6, x minus 6. And those, nothing cancels right now. So 6 minus x and x minus 6 are not the same thing, because here the 6 is negative, and here the x is negative. So what I could do in this case is on the top, I'm going to factor also. And I'm going to factor out a negative 1 from those two things. So I'm doing like reverse distributive properties. So here, negative 1 times what would make me end up with 6 is negative 6. And negative 1 times what would make me end up with negative x? And that'd be plus x. And you can always check if you reverse distributed properly by distributing. So if I do this, I should end up with, I get what I started with there, and I do. And now, things cancel. So the negative, the 6 is negative, the x is positive, the 6 is negative, the x is positive, so these two go away. You end up with negative 1 over x plus 6. Now I can plug in 6. And I would get negative 1 over 12. All right. The other way you could do that is to look at this, and you got your 6 minus x up here. And we typically go, okay, that's x plus 6, x minus 6. You could technically write it the other way. So 6 plus x, 6 minus x. Nope. That's a lie. That's not going to work. We're going to pretend we never said that. All right, let's move on. So stick with that first method I showed you. Let's say the limit as x approaches 0 of x squared minus 2x minus 8 over x squared minus 4x. So again, if I plug in 0 right now, well, here I'd actually get negative 8 over 0. But the problem is I'm dividing by 0, and I can't divide by 0, so that's not going to work, so I'm going to try something else. And again, it looks like I can factor. That top, I'm factoring, like, okay, what multiplies to negative 8 and adds up to negative 2? And that's negative 4, positive 2. That bottom is a binomial, so we don't have a difference of squares here, because I can't take the square root of the 4x, because that x is there. I don't have a trinomial, so it's not like multiply to this, add to this. it's reverse distributed. So what can I take out of both of those and put in front is an x. And if I pull an x out, so I pull an x from x squared, what's left is x. If I pull an x from 4x, what's left is 4. Those go away. I get x plus 2 over x, and crap, this one doesn't work. So there's a rule we're going to learn later to handle this. We have not learned it yet, so actually skip that too. That process is still good to understand what to do, so I'm going to leave it in the video. I'm not going to edit it out or anything. But here we do get stuck because we end up with 2 over 0, and you can't have that. So we'll address this one in a later class period. Let's say limit as x approaches 5 of x squared minus 25 over x squared minus 2x minus 15. So again, if I plug in 5, I'll get a 0 on the bottom. I'll get 0 over 0 this time, but 0 on the bottom is what really makes it so we can't do the problem. But I look and I see that I can factor. So the top I can make into x plus 5, x minus 5. The bottom, that's a trinomial, so what multiplies to be negative 15 and adds up to negative 2 is negative 5 and plus 3. Those go away, so I get x plus 5 over x plus 3, and then I can plug in, and I will get 10 over 8. And I would just leave it. If you leave it, it's fine. If you reduce it correctly, it's fine too, but if you somehow screwed up in the reducing part, you would actually lose points. So I would prefer that you just leave it as 10 over 8. All right, little different kind. Let's say limit as x approaches 0 of, 4x to the third minus 8x squared over 6x to the third minus 5x squared. So we plug in, you get 0 over 0. And this is kind of another different kind of factoring. What I'm noticing here that has not been true in any other ones is that there's 4 terms here. Terms are separated by plus or minus signs or by the big division bar. So there's 4 terms here. This guy, this guy, this guy, and this guy. And there's actually something that is in common in all 4 of those terms that you can just cancel out, just get rid of and just eliminate. So there's an x squared in each one of those. So what I'm going to do is take an x squared out of each one of those. If I took an x squared from this, what would be left is 4x. If I took an x squared from this, what would be left is 8. Take an x squared from here, we get 6x. Take an x squared from here, and we get 5. Now, I can plug in 0. So now I'd get 4 times 0 minus 8 over 6 times 0 minus 5. So negative 8 over negative 5, and that's a perfectly legitimate answer. If you want to get rid of the negatives, that's fine too, but you do not need to. So there's kind of, I think I just did 4 different factoring kinds, maybe 5. And the trick is, and what we'll practice a lot, is, okay, here's a problem. How do you know which one to do? And just recognizing which one to do at which time. Hopefully, we'll get better at that through practice. All right, sometimes you will have to expand. So kind of like the opposite of factoring. So let's say the limit as x approaches 0 of x plus 4 squared minus 16 over x. So, the ones before I was looking at, okay, that looks like I can factor. This does not look like I can factor. It already is factored. Like, that is the factored form. But I can do the opposite. So I'm going to actually expand this. So I'm going to do x plus 4 squared. Now remember, when you do x plus 4 squared, if you're doing x plus 4 times x plus 4, you get x squared, you get 4x, you get 4x, you get 16. So you get x squared plus 8x plus 16. A binomial squared is a trinomial. So don't tell me this is x squared plus 16, because you'd be forgetting that middle part there. All right, so it turns out to be x squared plus 8x minus 16. Oops, plus 16. And then that's just this part. Then you got the minus 16 that's still there. And then you got the x on the bottom. So once I get to here, things start kind of magically going away. So positive 16 minus 16 is gone. Now I have 3 terms, and what's in common is an x in each one. So I'm going to take an x out of each one of them, which would leave me with x plus 8 over 1. Because if I divide x by x, I get 1. Now I can plug in 0. 0 plus 8 over 1 would give me an answer of 8. All right. Similar kind here, but with what to you guys is probably a goofy variable. So let's say the limit as delta x approaches 0. Delta x is the change in x. It's different than x. X plus delta x squared minus 2 times x plus delta x minus parentheses x squared minus 2x over delta x. Plug in 0 right now, it's going to give you 0 on the bottom. It's not going to work. So we're going to expand. And again, when you're expanding, remember a binomial squared is a trinomial. So the shortcut for that is we take the first term and we square it. We multiply the 2 terms together. So x times delta x is just x times delta x. There's nothing you can do with that. But there would be 2 of those. Just like there were 2 of these 4x's, there would be 2 of the x delta x's. And then we take the last term and square it. So delta x squared. Distribute here, so minus 2x minus 2 delta x. Distribute here, there's a negative 1 there we got to distribute through, so minus x squared plus 2x all over delta x. And again, it's kind of, the magic happens now. So first I'm going to look and see common terms. So I've got an x squared there, a negative x squared there. Go away. We've got a negative 2x here and a positive 2x there. Go away. Now I've got 1, 2, 3, 4 terms, and they all have a delta x in them. So let's cancel out a delta x. Here that would leave me 2x. Here I'd still have a delta x. Here I'd have a minus 2. And here I'd have a 1. Now plug in 0, and you won't get 0 on the bottom. You'll have 2x plus 0 minus 2 over 1, which is 2x minus 2, and that's your answer. There's nothing we can do. We don't have an x value to plug in, and that's a legitimate answer. And you'll see kind of why that is as we go throughout the year. All right, a third technique that you have to use. So we've got factoring, and there's different kinds of factoring. We've got expansion. There's also rationalizing. So rationalizing, when you have a square root in your problem, but it's kind of in your way, so we're going to figure out a way to get rid of it. So let's say I had that. Well, if I plug in 9, I'm going to get 0 over 0. So I got to try something else. So what I'm going to do is I'm going to multiply the top by x, the square root of x plus 7 plus 16. It's called the conjugate. If I do it to the top, I got to do it to the bottom. But the bottom isn't really the important part. The important part is the top part. Well, they're both important, but so what you have here is something that you need to FOIL. So if you think through that FOIL, the square root of x plus 7 times the square root of x plus 7. If you think about like the square root of 9 times the square root of 9, that would be 3 times 3. That's 9. So the square root of 9 times the square root of 9 is 9. The square root of 16 times the square root of 16 is 16. The square root of x plus 7 times the square root of x plus 7 is x plus 7. Your outside and your inside in the FOIL are going to cancel. Your outside would be positive 16 times root x plus 7. Your inside would be negative 16 times root x plus 7. So they just go away. Your last would be negative 16 times positive 16, which is negative 256. this should have been a 4. This should have been a 4. This should have been a 4. So the negative 4 times positive 4 is negative 16. My fault. On the bottom, I have x squared minus 81 times the square root of x plus 7 plus 4. Well, I still can't plug in 9 because of this. If I plug 9 in here, 9 squared minus 81 is 0. So we got to work with that a little bit. Well, this up here is really just x minus 9, which all of a sudden makes me realize, oh, I should factor that also. Because I can factor that to be x plus 9, x minus 9. And then just kind of drop this down. Now those cancel. I'm going to have a 1 up there. And now I won't get 0 on the bottom. So now we're in a much better spot. So I can plug in now, and I'd get 1 over 9 plus 9 times the square root of 9 plus 7 plus 4. So 1 over 18 times, this would be the square root of 16, which is 4. 4 plus 4 is 8. So 1 over 18 times 8. So 10 times 18 would be 180. But that's too many 18s, so I need to subtract 36 from that, which puts me at 144. And those are certainly the toughest ones, and we will, I'm sure, go through at least 1 or 2 of those in class. I'm going to move on for now. But we would, like I said, we'll definitely go through some, and this is even another example of that. It's just a little different. Alright, let's look at this one. So again, I got a square root there. If I plug 25 in, I'll get 0 on the bottom, so I'm kind of stuck. But I can rationalize again. So I want to rationalize by, wherever the square root is. You're going to multiply by the conjugate. So the square root of x minus 5, the conjugate is just the same numbers with the opposite sign here. So I'll multiply by the square root of x plus 5. But if I do it to the bottom, I've got to do it to the top also. Now FOIL again. So the square root of x times the square root of x is x. Outside and inside will cancel. Square root of x times 5. Negative 5 times square root of x will go away. Negative 5 times 5 is minus 25, which is good because of what we have on the bottom. So now those just directly go away. I got a 1 on top. I can now just plug in. Square root of 25 is 5, so this becomes 1/10. Alright. So again, we'll look at that tomorrow in class. I'm sure we'll probably go through a couple of those too. One more type of problem I'd like to show you. I know this is a lot, but again, we'll practice this quite a bit too. So this is something that you should memorize. The limit as x approaches 0 of sine of x over x is 1. The graph for that kind of goes like this. And so if I look at the limit as x approaches 0, the roads are heading toward a y value of 1. So what they'll do with that is ask you questions like this. So let's say 3 times sine of x over 4x. Well, all you're doing there is you kind of think about it like this. So if I look at it as 3/4 times sine of x over x, and then think about the limit as x approaches 0 for both of those. What's the limit as x approaches 0 as 3/4? Well, there's no x involved in the 3/4, so I don't care what x is. 3/4 is just 3/4. What's the limit as x approaches 0 of sine of x over x? Well, it's 1. That was what we learned a second ago. Multiply those two together. Your answer is 3/4. So if you memorize that sine of x over x, I mean, really, you could kind of look at this problem and just be like, okay, that part's 1, that part's 3/4, multiply them together, boom, 3/4. Let's say the limit as x approaches 0 of sine to the third of x over x to the fourth. No, x squared, let's say. The way we could think about that one is I could rewrite that as sine of x over x, sine of x over x, sine of x. Because then I got my sine of x cubed, I got 3 of them. And I got my x squared, I got 2 of them. Well, this part is 1. This part is 1. This, well, I'm just going to plug it in. As x approaches 0, sine of x. So what is the sine of 0 degrees? Well, at 0 degrees we're over there. The y value is 0. 1 times 1 times 1 is 0. So it's just kind of working with, you know, you're supposed to know this, memorize, understand. You're going to have to use that, and then, okay, can we kind of manipulate things around that and use it for examples that have to do with that. Alright, so I know that was a lot. Like I said, we'll practice some more, bring questions, and we'll practice on Monday. Have a great weekend.